Okay, hi everyone. We're going to do a little open boxing of this Astro 6,000 count true RMS digital meter. I got a request from one of my viewers on my channel about the meter that I use in a lot of my videos or circuits, and I thought I would give you guys an update on that. So we're going to do a little open boxing. Excuse me, I got a little cold also, but anyway. Yeah, we're going to see what's in the box. You get an instruction manual that's pretty straightforward. It has information in here about how the functions work and everything like that. We'll go into that in a moment. I'm just going to set that aside. You get your probes, some general purpose digital probes here. You get the meter, of course. This is the MK. Let me pull it out here. This is the M6KOR model. It's a 6,000 count intelligent hookup meter. I'll show you what that means in a moment. I'm just going to set that aside. And also in this one you get a temperature probe, which is works with the meter, and it lets you detect the temperature of solid state devices just with this little tiny tip. So we'll show you how that works too. I'm just going to set the box down out of our way, and we're going to talk about this meter. This meter has a bunch of functions on it. Has a dial control that does a lot of things. When you first switch it on, it's auto ranging. You notice these are flashing. These are the intelligent ports. Let you know that, let's say if you when you set it on that, which one of the holes you plug these probes into. Okay. So, if you put it on, like amps, move it on to microamps. If you're moving on to something bigger, it'll tell you this goes up to 10 amp range, so it'll measure. If you put the probes in here, you can safely measure 10 amps. I don't usually use the amp area for big amps, and most of my circuits are small voltage type of circuits. This device also has a non-connection live line indicator, meaning if you bring it within range of AC source, like I'm going to do right now, it's going to let you know that that you have AC going on there. It's a live line. See, it's measured. It's turned to a high red letter that lets you know that line that you're measuring is got active AC in it, which is something you might want to know when you're around wires and you don't know if they're alive or not. So what we're going to do, I got some stuff here that I'm going to show you the functions of this device using some actual components. I got an LED, I got a diode, I got a resistor, and a capacitor. And I'm going to show you what this meter can do when it comes to devices like that. So give us a brief moment and we will be right back. Okay, everybody, I'm back, and I'm going to. I took a look at the last video piece that I shot, and I saw that you didn't get a chance to see the live line detector portion of it correctly. So I'm going to just redo that for you. Like I said, this has the ability to detect if you're near an active AC line. So we're going to switch it over to that right quick. And normally, let me come back a little bit. If you're not near an AC source, there's nothing going on. It just says NCU. But when you get close to a line, like a live line like this one I'm holding in my hand, you notice that it will let you know that you're near a line. And if it's a really strong source of AC, it'll turn to an H. So it lets you know how far away are you from a live line source. Alright, now, let me see, one of the things I want to do, let's get this hooked up. I'm going to hook the probes in right now and show you how we can test some stuff with this thing. We're going to go through some of the features, what it can actually do for you. It has a back stand on here. I forgot to mention it. You can stand it up like this, so you don't have to hold it. You can stand it up. And, excuse me, sorry about this coughing I'm probably doing through the video, but below here, there are two AA batteries, and you probably won't have to change them no time soon. But if you did, excuse me, all you have to do is just make sure this is off. Yeah, all you have to do is just take a screwdriver, open this up like this. We're going to unscrew this. I'm going to show you what's below deck a little bit. You notice though we got two AA batteries in there, and if your battery source start getting low, that's where you'll find it, right below this little cover, which has a little Phillips screwdriver bolt on it, and screw that back in. Excuse me. So that's how that works. These things on the back here are also places you can store your probe. So when you just put them in and you store it like that, you know, and you can put your when you want to put it away, you know, you store it like that, and the probes won't always be with the meter. But right now, let's go ahead and test some stuff. Let's have some fun with this. First, I'm going to turn it on. Like I said, it's auto ranging. Right now it's on DC. I can push that button and it'll go to AC. Hang on a second. Let me take a look at the monitor and make sure you guys can see what I'm showing you right now, because oh, that's a little bit better. Okay, like I was saying, this function button allows you to change from DC or to AC. So one cool thing about this meter is when you're testing AC sources, the screen also the screen is a backlit screen. It can be blue. Let's say if you're in a low light setting, you know, or something like that. I'll show you, like right now, you're in a low light setting, it's blue, right? Okay, so when you want to measure AC with the probes, this will let you know that you're testing AC. I'm going to plug this into a live AC line carefully, like though, and you notice it turning red. It's showing that it got almost 120 volts worth of electricity coming through these probes right here with 60 hertz. That's the speed of the alternating current. Okay, so when you're not testing that and you're just testing DC, like a regular battery like this, it won't turn red. It'll stay blue, and you know, it'll measure your voltage. This is a 4 volt. Let me see if I got that on there right. Right, hang on. I gotta make sure oh, sorry, I gotta put another thing. If you try to measure a DC source, a DC source with an AC setting, it won't do it. Push it back to DC, and then it'll measure correctly. See, so it's 4.1 volts. This battery is like a 4.3 volt lithium cell. Okay, let me put some lights back on so we can see again. All right, there we go. Now I'm going to show you how some things about the testing I want to do far as devices, the components. So let's say if you got a diode, not a diode, a LED like this one here. This can measure, it'll let you know if you got an open LED or a closed one that's functioning, one that's not functioning. This is the negative part of the probe, and this is the positive part of the probe. So I'm going to put the negative on the cathode part of the LED, and I'm going to go to, before I do that, we'll go to diode. So you want to go to that setting first, and this position here has two functions. You can measure for continuity and you can measure for diodes. So right now it's set with diodes, like that little symbol showing. So if I put the cathode or the negative on the cathode part of the LED, and that, you see, notice that LED turned red, and it's forward biasing at 1.8 volts. So that means that LED is good. Now if you accidentally was to connect this backwards, you won't get anything. And the reason why that is, LEDs are essentially diodes with a clear coat. So when you gotta look at it like that. It allows energy in one direction but not in the other. So that's why it works. But because it has a clear package, it comes off as showing a color. Now here's an actual diode with no clear coat. This is a silicon diode. It has a ring on this side, so that's going to be my cathode side. I want to touch that with the negative, of course. And you can see that has a forward voltage of 0.5. And if you try to reverse it, like we did with the LED, it's going to not do anything, because diodes work, like I mentioned, allowing current in one direction but not in the other. Okay. And if you want to measure resistors, you can move this thing to ohms. In the meter here, that little symbol right there stands for ohms. You can, with the function button, change this to capacitors too, microfarad. We'll do that shortly. But right now I'm going to go to measuring resistance. So I have a resistor here that's, and it don't matter which way you put this on here. You know, it's about a 10,000 ohm resistor, 9.7, or, you know, like about 10,000 ohms resistor. It has a gold band, so it's 5% tolerance, you know, either or, so, you know. All right, so now this little package here is a capacitor. I don't know if you can see that. Let me take a look and make sure you can see that little device. I might have to bring it up there, but anyway, this is a capacitor. This thing right here is you find it is in a lot of electronics. It's got a negative side and a regular side. And this is called an electrolytic type of capacitor, I mean, because it's polarized. So to measure capacitance, you use this function button here, and you go to, you got nanofarads and farads. So it'll measure this capacitor right here. If I put the probe, well, like I said, a negative, so let me put the capacitor measure on the right side. So I'll put the negative probe to the negative side of the capacitor, and the other one to the positive side of the capacitor. And this capacitor itself is 33 microfarads. Right now they're showing 33.5 nanofarads, or if you convert it, you'll get to 33. So it measures capacitance, and usually you want to measure capacitors out of the circuit, because if you measure them inside a contained circuit, you might get a false reading of some sort. So that's just for you to know that. All right, so give me a moment, and we're going to go into testing the thermal ability of this meter. All right. Okay, I'm back. I'm going to try to do this bit without coughing on you guys. So anyway, we want to turn the meter back on. And this time we're going to use the little thermometer or thermocoupler that came with the device. The little tip of this thing, it has a little tiny dot ball on the end of it. That's a little, it changes resistance according to temperature, so it makes the thermal have ability to measure temps. So the end of the probe has a positive and negative, so you want to put those in the proper slots. So just plug that in like that. And right now this probe is ready. So what you want to do now, this meter can measure in Celsius and Fahrenheit. So we're going to move it to it's going to auto calculate it. Top part of the meter is going to show in Celsius. Like right now, the ambient room temperature is at 77 according to this meter, 25 degrees Celsius. So let's say if it's, you notice at 77 now, let's say I got a lighter here. Let's say if I was to heat the air up slightly, watch what happens. I'm just going to light that real quick. I'm not going to light the thing itself, but I'm just going to heat the air up. You notice how the jump just jumped up. Look at the temp. See how it changed up there? So let's say you're working on a circuit, and you have a device, and it feels like it's warm. You can take this little tip, like this. Take the little tip and just touch it to the device, and it'll change. It'll read if it's overheating or not. That's the purpose of this tiny probe, is to measure if you have a runaway thermal on one of your devices. So it's handy for that. So we can unplug this now. Let me see if I can get it out. Yep. I'm gonna set this aside. I want to talk about something else also. This thing has a hold feature, meaning if you measure something, like, let's hook the meter back up for a moment. We're going to measure something, and we're going to put it on hold. Right now I'm just going to plug that in. I hope you guys can see that. Let me see. Yeah, I guess you can. Okay. I'm going to move this to ohms again. We're going to measure resistance with the resistor here. So I'm just going to just hook this in here. Get the resistance I want, find the resistance I want. I'm just going to hold that value. And even when I remove the probes, you notice that resistor, that value is sticking around, it's hanging on there. And that's handy for if you're working in your car and you want to get a quick reference voltage. maybe from under the hood compared to inside the car. You can do that. And that's another thing about these meters. They're perfect for home and auto use. You know, you can use them in your home or auto. I have one of these in my car as well for emergency, in case I want to know what the battery's doing, if I have a short circuit going on or anything like that. And I have one in the house there when I can do household currents, AC stuff like that. Okay. In the manual you'll get itself, it kind of explains everything to you about the symbols. It has little symbols referring to the little symbols you'll find on the meter itself. So like, you know, like DC voltages, AC voltages, resistance, capacitance. All these are spelled out here in the manual. And, you know, it's not that many pages, so it's not a big learning curve you have to worry about. So, yeah, it's about, let me see how many pages. It says about 22 pages. But it's handy to have it. Excuse me. I'm going to make this video kind of short because I'm really having a hard time with my allergy/cold. So anyway, but I hope you guys was enlightened a little bit about the meter. And I hope this kind of shine a little light on the abilities you'll have in buying one of these meters. It measures frequency also in hertz. I don't have a frequency counter out here. This device is a voltage thing here, power supply. But I don't have a frequency thing, but it will measure frequencies for you quite accurately. And like I say, it has a simple one button operation type of thing, you know. And so that's pretty much about it. If you found this video informative, just give us a like, you know, something like that. But that's all I really have for you today, and I hope you guys have a great day.